All right, we're on 181, where we kind of want to be. If we take the integral from a to b, we're basically going to find the area under the curve. Okay. It is possible to have negative area if it's below the x-axis. However, when we're talking about actual area, you can't have negative area. So that's why in the parentheses it says quote unquote signed area. Okay. And it is possible to have zero area if the amount of area above the x-axis and the amount of area below the x-axis are the same. But if we're trying to find actual area, it can't be negative. So you have to watch out for that every once in a while. Okay. General, what you're going to do is you're going to subtract the two curves that we're talking about, and you're going to integrate, take a definite integral between a and b. It's got to be a closed interval. It also assumes that your curves are continuous, and then in this particular case, f of g is greater than, f of x is greater than or equal to g of x. And so we'll get into that a little bit more. There's some sort of general ways to express it, sort of like the top equation minus the bottom equation. That's kind of what this means here, and we'll write that explicitly in a minute. This is a very general picture. You can draw and color as much as you want, but it's really more important to kind of watch what I'm doing just so we're clear. I know you've done this before, but let's just do it real quick. So here's an example. Thought I didn't have it with the colors. Well, that's disappointing. Let's do this. So here was the actual problem. I was trying to kind of go one piece at a time. Anyway, so if this f of x greater than, so that one's above, g of x is less than. So we're trying to find the area in between. Really what we're going to do real quick. So here's an example. Thought I didn't have it with the colors. Well, that's disappointing. Let's do this. Is we're going to first, essentially the way you think about it is, if I just integrated f of x over this interval, it would give me all of this red area. Okay. If I just integrated g of x over this interval, it would give me this blue area. And so if I basically take the red, which is the whole thing, and subtract off the blue, I end up with purple, of course. No, that's cute, right? Anyway, so that, again, more explicitly, that's the top curve minus the bottom curve. And this is for functions of x. So one of the things that's going to change in this unit that maybe you're used to because you've done it before, but we don't spend a lot of time looking at functions of y. We spend most of our time talking about functions of x. So when that happens, okay, if you have a function of y, it's going to be the right curve minus the left curve. So because the right values of x are bigger than the left values of x. Just like here, the top values of y are bigger than the bottom values of y. So that's this is all kind of review, yeah? All familiar, good. All right, we'll get into some examples and kind of go for it, and then we'll be good. All right, so here's the first example, example 1, same page. We got the area of this region, so it's already drawn for you. I will say, if you're ever in a situation where they don't draw it for you, which is going to be fairly common, I highly, highly recommend drawing a picture. Once you can kind of see it, it makes it a lot easier to figure out how to match an equation to it. So we've got 4 equations here. Our first one, y equals x squared plus 2, so that's our little parabola up top here. The line y equals x. I know this is not to scale. X equals 0, so that is the y-axis. And x equals 1. And the area where they intersect is all just in between there. Okay. Do you want to try to find the area on your own, or do you want to go through it together? since you're already working on it, how about oftentimes when the problems get a little more complicated, you'll be asked just to set it up sometimes, and sometimes it'll be, yeah, you can use a calculator and just punch it all in that way. From problem to problem, it kind of varies. So it's important with these types of problems, with area, with volume, that you're paying really close attention to what the directions are allowing and what they're asking you to do, allowing the idea of whether or not you can use a calculator, and then whether or not you're actually finding the area or volume, or you're just setting it up. Yeah, a problem like this, they wouldn't let you use a calculator. It's too straightforward, and the numbers are fairly easy, and the integration is fairly easy, relatively speaking. So our top equation here is the y equals x squared plus 2. Our bottom is y equals x. We're integrating from x equals 0 to 1. Hopefully that's what you had. Okay. Then it's just straightforward integration. Okay. And again, more visuals in case you were needing to see that. All right. So when I integrate this is x cubed over 3, or you could say 1/3 x cubed. It's fine. 2x minus x squared over 2. We're integrating from 1 to 0. The great thing about this, they all have x's, so this part's unnecessary because we're just going to be subtracting 0. So it's just a matter of plug 1 in. So 1/3 plus 2 minus 1/2. You could leave it like that, but if we're talking about area, I feel like I want to have a number. But if you were on the AP exam, you could leave it like this, and that would be fine. Okay? How many of you had that? Or some equivalent value of that? I mean, technically, we're talking about area. I get in the habit of doing this. We should probably have units in there of some kind. I know they don't give it to us. I don't know how nitpicky they're going to be on the AP exam about it, but better safe than sorry is the way I kind of feel about that one. All right, let's look at another example. Now, this one they didn't draw for us, so we're going to sketch it. Okay, and in your homework problems and on your test, there's going to be some opportunities for you to do some sketching. So this is the situation. Okay, we've got two curves to determine the boundaries. Okay. You're going to have to, oftentimes with problems like this, you're going to have to find the limits of integration. And even though you can, if it's a calculator problem, find those areas of intersection, those points of intersection on your calculator, you still have to show the setup for it, like what you would do if you were going to do it by hand. And so in this problem, actually, we are going to do it by hand. But this is example 2. Okay. And one of the key things about this problem, why I chose to do this one, is because it is of y instead of x. So we kind of have to flip our brains around a little bit to figure out what's going on here. Okay. One of the things that should stand out to you right away, since they're talking about, they're explicit about a function of y, especially this one here, the parabola always gives it away. When the squared term is on the y instead of the x, we're talking about a sideways opening parabola. Because of that, this equation should throw you a little bit, right? Because this is sort of in terms of x instead of being in terms of y. Either way, its graph's the same, but that's going to come into play here in a minute. So go ahead and draw sketches of those two lines, of those two functions, and we'll kind of see how to go from there. So your sketch should look something like that. It's not completely imperative that it's perfect, but I think it's important to get a sense of what's going on. Okay. The trick here for our limits of integration now, we are going to be finding what this y value is, and we're going to be finding what this y value is. Now, in this particular case, I would not trust the graph. In general, I would not trust the graph. And when you get into the sort of statement above the example, it talks about that setup, okay? So if you just went ahead and said, oh, it's -1 and 2, and I can tell from the graph, like that won't get you credit on the AP exam. That I definitely know, okay? So it's important here when we're looking for those limits of intersection to not trust the graph for points of intersection. Don't do it, okay? You really want to see that mathematical justification for a situation like this. So in this case, I need to find where they intersect, okay? And even if you're doing it on a calculator, now in our case, we're not going to, because this is pretty easy. And this kind of gets back to what I was talking about with this equation before. We want it in terms of y instead of in terms of x. So I just kind of flipped it around to get it in terms of x, because what we're trying to figure out is when does this y squared minus 3 equal y squared, or sorry, y minus 1. And so my setup in order to find that is just that, to say what values, what am I doing? What values of y are true when those two things are equal. So go ahead and solve that one. You don't need a calculator to do that. You can do that by hand. Now it turns out my diagram is actually pretty good. So they were -1 and 2, and hopefully you were able to find those. Just a little quick factoring. We've got a quadratic, get everything to one side, and then we're good to go, okay? All right, so now go ahead and actually finish the problem, okay? Go ahead and find the area between the two curves. Now that we know the limits of integration, we have everything we need. So go ahead and finish that one up now. All right, so here's my setup. Okay, my right, in this case, my right function is x equals y minus 1. Subtract off the left function. This should be your setup. Okay. Then it's just a matter of simplifying and integrating. I mean, in reality, there's a couple different ways you could do it, but I mean, you could, it's basically this, except the signs are all flipped, right? So in this case, I moved everything to the y squared side. The way the integral is set up, I actually have to take all of this and move it over to here. And so it's minus y squared plus y plus 2. So when I integrate the opposite sign of this, it just ends up giving me -y to the third over y plus y squared over y plus 2y, right? So then you have to plug the 2 in, plug the 1 in, and do your subtraction. And again, on the AP exam, if you could leave it like this. That's an acceptable answer. For that matter, you could plug the 2 in and leave the powers and not even simplify like I did. I did a little bit of simplifying, just so you know, you can do that. I'm sure I went and finished it. 9/2 is what you should have gotten. And again, I'm going to contradict myself a little bit. I think I want units on there. Okay, you could put 4.5, you could put 4.5, any of those things are fine, okay? Something we're going to go through this last example here, okay? And I'm going to show you this for a couple of reasons. And I'm going to show you something on the calculator for a couple of reasons. I think it'll make your life a little bit easier when I show you what I'm going to show you. Maybe you already know this. I don't think you do, because based on what I've seen some of you guys doing, I think this will be new. All right. So in this case, I have two functions. F of x, this is a calculator problem. F of x is a cubic. G of x is a quadratic. So in order to right away tell which one is which, right, we got to figure out which one is the cubic, which one is the quadratic. Of course, what we're going to be doing is essentially taking the area of this and combine it with the area of that. So I've got I'm going to sketch this real quick, or outline it, I guess. Do it in a different color. So here's my cubic, right? So that's my f of x. And then of course my parabola, and that negative gives it away, right? That it's a downward facing parabola, okay? So just in case you're having trouble telling which one was which. I think sometimes that's helpful. So if you notice here, right, in one case, over here, I've got the g of x on top and the f of x on bottom. But over here, I have the f of x on top and the g of x on bottom. In other words, I'm going to have to set up an integral for this, and I'm going to have to set up another integral for this. In particular, I know that I can't just write one integral from -2 to 2 if those are the limits of integration, which they aren't, by the way. But they're around there. But I am going to have to set up two separate integrals with two separate limits of integration. Of course, it looks like it's pretty obvious where they intersect here. But just again, to me, I want to go through just the ideas here, right? For this, my red one, I've got F on top and G on the bottom. And for the blue one, I've got G on top and F on the bottom, okay? And that kind of leads us to where we're going. Now, one of the things that I've seen in our book is sometimes they like to leave stuff like in terms of G and in terms of F. I'm not 100% convinced that doing that is acceptable on the exam. I think you often do need to substitute in what the value of the function is, especially if they're asking you for an answer, okay? In this case, it's not asking us for an answer. It says set up integrals, okay? So we're not going to be finding the actual area. We're just going to be setting them up. And so what the bulk of this problem then boils down to is figuring out what these limits of integration are. I made an assumption here just by looking at the equation and also at the graph that one of them is 0. They intersect at 0. Since I have x's on each side and I factor out an x, I know that 0 is going to equal 0. This is probably too soon to just assume that it was 0. Okay, but what we do need to do is we need to find the solution to this equation when I set f of x equal to g of x and figure out where that is. So go ahead and solve that, okay? That is definitely a calculator situation. Of course, one of them is 0. You can tell that pretty easily. But go ahead and solve that and let's see what you end up getting. All right, so here are the values you should have had, okay? So of course 0 was one of them, like we mentioned before. Negative 2.025 and then positive 2.025. And where those come into play is obviously this x sub 2 is my negative and this x sub 1 is my positive. And so we're just going to plug those in for my, okay. So again, this one was my x sub 2, this is my x sub 1. And this is the setup that you would have. Now, I think this is a better way to go than this because a problem like this, if it was a free response, is probably going to ask you about more stuff. It's going to say, okay, now that you have the area, calculate the volume of square cross sections or something like that, okay? And at some point, if you wanted to actually figure this out, you could. Now, that's the part I want to show you. Because one of the things that I know, like some of the problems that you had to do for your homework today, you know, you often use the same equation over and over again. And something I don't think you're familiar with is something that I want to show you. And it's all in the y equals 2. Let me see if I can do this. Because we've got it in there 1, 2, 3, 4 different times. Okay. What you can do, let's say that we were actually going to solve this. And you didn't want to have to type this in every single time to do your integration. Is you can use your y equals screen and you can tell the calculator to just use y1 or y2. So when you hit alpha calc on any screen, okay, and in this case, it wouldn't make any sense to do it on my y equals screen. It would make sense to do it, you know, on your regular calculation screen. You can, for that matter, when you go to put your, you know, you do your math 9 to get your definite integral, instead of having to type it in every single time, you have it stored in your y equals screen. You could set up a definite integral that had y1 and y2 in it, since you've already determined what it will be. So, again, I know it didn't ask us to calculate it, but I thought this would be a good time to show you this. Instead of having to type this in manually every time, once it's in the y equals screen, to find your definite integral, if you were going to find, I get there's another one that had the negative down here and a 0 up here, and these reversed. But just know that this exists in your calculator where you can type stuff in the y equals screen and then you can find the definite integral without having to type the equation in over and over again. You can just recall it from the y equals screen using this alpha trace. Okay? I don't know if you did.
Miss Schreiner kind of taught us.
She kind of showed you that?
Yeah, it's still using the vars, but there's like different
You
vars.
click the vars button and then.
So then you got to go into a menu and find all that. This is the shortcut. So there's a couple things, and I was talking to Sophia about this morning. So alpha trace will get you all your y's. Alpha y equals will get you your fractions without having to go into a menu or anything. I don't know what the other ones will do. What is that one? Oh, alpha window will get you some of your shortcut ones that you want to get to. Absolute value, for example, is there. Alpha zoom, that's you're getting into tables there. And alpha graph apparently is a graph. Well, maybe I didn't hit alpha first. Alpha graph. No, that doesn't do anything. So anyway, some of those shortcuts. Again, we're talking about speed, right? So alpha trace will get you your y's. Alpha y equal will get you your fractions, that kind of thing. But yeah, you can. Obviously, there's lots of different ways to get it. Okay. But I think what I want your takeaway to be is when you start getting into some of these problems that are actually asking you to find answers, which I realize we didn't ask you to do on that one, you can enter them in here into your y equals screen and then use them, and it'll save you some time, because I know, like, if you do this and you're like, oh crap, I lost it was 4th power instead of the 3rd power, and then it just sort of messes you up the rest of the way. It's just something worth